Good day everyone. Welcome to the course on biological data analysis and visualization with R. In the last few classes, we have looked into basic statistical tests followed by correlation analysis, ANOVA, etc. And then we talked about data visualization, starting with very basic visualization including histogram, etc. And then in the last class, we talked about ggplot2, how to make visualization with ggplot2. So, we'll be continuing that discussion today. So, we'll extend this application of ggplot2, right. We'll use a function called ggscatter, and we'll do some plotting with ggscatter, and I'll demonstrate how we can make very nice plots with ggscatter. Followed by that, we'll talk about some R packages that are required for data organization. Again, these packages we are building up the base, which we will use later on starting from the next week for our data analysis. When we apply all these techniques, visualizations to specific data sets for doing much more complex analysis. So, let us begin. In this class, we will be talking first about plotting with ggscatter plot, and then we will talk about data organization, specifically with a package called tidyr. So, we will talk about tidyr package in this class, and we will talk about another data package in the next class. So, first up we will talk about package ggscatter. So, how to make scatter plot with this package, and what we get here is scatter plot with trend line as well as confidence interval. So, most of the confidence interval that we get is usually 95% confidence interval. We can change this, we can also make 99% confidence interval, but the tradition is to make 95% confidence interval. So, what it means is the measure or statistic, whatever we are saying here, the trend line, right, with different samples for 90% of the times it will fall within that interval. So, that is the idea. So, that is why we want to get this confidence interval. This is something we will discuss about later on when you actually make the scatter plot and we add the trend line and the confidence interval. So, once we do that, we will talk about the data organization part, and we will use a package called tidyr. This is an R package. This helps us in organizing data or tidying up data, and it is part of an tidyverse package in R. So, what does this mean? So, we have talked about data frames already, right. So, we have talked about metrics, we have talked about data frame, etc. So, different data structures we have talked about. So, what is tidyr package supposed to do? So, the idea behind tidyr package is we should have tidy data, we should be working with tidy data, so that our analysis we should be focusing on the analysis rather than data format and organization, etc. So, this should be clear. The advantages of using tidy data and tidyr package would be clear, and we will use some of these extensively in later part. So, a data is tidy if each variable is in its own column and each observation sample is in its own row. Okay. So, that is the first principle. So, you have to have variable, the features or the observation features that we measure, for example, for observations, those should be in their own columns, and each observation should be in row. Okay. So, this is something we follow, and then there should be only one value in a cell, right. So, from here it looks like data frame, right. So, which we have already seen. So, what is the special thing about tidy data? So, there is a new data structure here that is defined, is called table, and this is built on data frame. So, this is something follows the data frame format, but it actually has some advantages and some differences compared to a data frame. So, we can create a table by using the command table. This will actually put the data by column, or we can use the command table, which will put the data by row. So, we can also convert data frame with this as table command, right. So, we can move the data frame to a table format, and this actually is sometimes very useful when we are working with a big complex data and you want to do some statistical analysis as well as visualization. So, what are the differences of table compared to data frame? Okay, so let's look at that first. So, one of the things why table is used is that it would not change any data type, right. So, this is one of the things we sometimes face in data frame. So, whatever you do, the data type will not change. Okay, so we have talked about data type, right? Numeric data type, character data type, logical data type, etc. So, whatever you do, the table in a table, the data type will not change. The second advantage and difference compared to data frame is that it does not change the names of the variables. Okay. So, when we are talking about data frame, I briefly mentioned that your column names should not contain space or special characters because R will change them. So, table actually can handle all those things, right. It can handle space, it can handle special characters. So, it will not change the name of the variable. The other thing that is different compared to data frame is when you subset, right, we want to take a subset of the table, it will always return another table. Okay. So, whichever way you do the subsetting, it will always return a table. Whereas, for data frame this is not the case, right. For data frame sometimes some subsetting will return a vector and some subsetting can return a data frame. Okay. So, this is something that can get confusing when you are analyzing data and you do a subsetting. Depending on the subsetting, you might get a vector or a data frame. So, that could be problematic for your subsequent steps. However, the difference is in table row names are not allowed. So, this is something we should keep in mind. Now, let us move on to the tidier functions, right. So, we have discussed the table data format, data structure, which is very similar to data frame, but it has some important characteristics which could be useful in our applications. So, now we can apply these tidier functions on table as well as data frame. We will do that in hands on, we will see how we apply these functions. So, for example, we can combine and split cells, we can reshape data. Okay. We will see what I mean by reshape, we will do some hands on again. We can handle missing values with tidier. Okay. So, so these are some of the tasks that you can do. There are many more actually that we can do. So, the first part, right, the combine and split cells, we can use this command unit and separate. Again, I will demonstrate this, but just to briefly mention what these are, unite and separate. So, unite function, what it does, it actually can merge columns, right. So, it can unite columns, right. So, you can see here, just as an example, you have a table and let us imagine, right, we are looking at gene expression of gene A and there are two isoforms, iso 1 and iso 2 in two different samples, sample 1, sample 2. Okay. What unite will do is it can merge these two columns into one saying gene A, and then it will also put this value separated by this slash. Now, this is the command we will again implement in R, is unite the data frame or table and the columns that you want to unite and the new column name that you will give, followed by the separation that it should use for uniting, so adding these values of these columns. Okay. So, when it is putting them together, these values together, what should be the separator or the delimiter. Okay. So, this is something we have to use, and we will use this in the hands on part. So, this is the combined part. We can split cells as well, right. So, let us imagine we are working with now that combined data and the command is separate. So, this is how the separate works. Separate the united data frame or the united table that we had created in the last step. The column that you would want to separate is the gene A, followed by the separator or sep, right. This is the separator we should use, and into column what are the column names, new column names that it should create. Okay, so into C, gene ISO 1 and gene ISO 2. So what happens when you apply this command? This data frame or table gets converted to this one. Okay, on the right, you can see this 54 by 63. This is now separated because we are using this separator. Okay, slash. Okay, so these are some of the commands. Of course, there are other ways to do this, and the other way of doing this separate command is called separate longer delim. Okay, so what you do is actually from this table, the data frame that we created by uniting these isoform expressions, we can create a longer table where we can use this, right. So, for example, we can have this, instead of putting them on a new column, we can put on a new row. Okay. So, again the command is very similar, right. So, here we have separate longer delim, and the data frame that you want to separate, where we want to separate a column is this column, right, that we want to separate, and this is the slash. So, separate this by slash, but instead of a new column, create a new row. Okay. So, this is what we get at the end. Okay. So, we will see this in the hands on. Okay. So, these are the combine and split functions for tidyr. We also have the reshape data functions, and this is something we will use later on when we apply it for more complex analysis. Okay. So, there are two commands that we will be talking about. One is called pivot longer, another is pivot wider. Okay. So, it is kind of again what we have seen just before this is the separate longer, etc. So, similar idea, but this is how it works. So, pivot longer means it lengthen data by collapsing columns into two columns. Okay. So, here for example, we let us say pivot longer, we take the data or data frame that we want to apply this function to, the columns, the column names, right, that you want to collapse, right, and the names 2 and values 2. Okay. So, names 2 means what it will do is it will actually, so let us say if we want to collapse these two columns, right. So, this is slightly different from what we have seen, the separate, etc. So, if you want to collapse these two columns, it is asking where should these names go. Okay. So, these names will be put on a column, and the values under these, right, here and here, they will be put on a separate column. Okay. So, you have to mention this where these names of the columns and the values of the columns will go. Okay. So, you can do this for multiple columns, you do not have to have just 2, right. I am showing here 2, but you can do this for multiple columns. We will see in a moment in the hands on how this works. So, I have not drawn written it here, it might get a bit confusing, we will do the hands on and we will see. There is the pivot wider function. So, pivot longer, as you can see, it will create new rows, it is collapsing columns and it will create new rows, and pivot wider is actually the inverse of pivot longer, right. So, it will actually widen data, right, by creating new columns from rows. So, it is something we have seen. So, if we had created an object by this pivot longer, you actually can again restore this by saying pivot wider. Okay. This is the format that we will use. So, pivot wider, we have the data frame that we have to give, and then the names from, right, where should the names come from. So, you have to mention the column from which these names of these new columns that will come, right, and values from where the value should come from for these new columns. Okay. This is something you have to specify. Okay. So, we have seen some functions now, reshaping data using the pivot functions. There are again many more functions. I will show you in a moment where you probably can find it, maybe just towards the end. So, this tidyr can also handle missing values. There are commands that can help in handling missing values. So, for example, there are two functions that you can use, is called drop NA. So, if we have NA values, it can drop those, or you can also say replace NA, right, and you can say give the data and then you can mention where the values are. Okay. So, again we will see some examples with so it will say like columns means which columns you should drop, right, where the value Na value might be found, right, columns, and replace Na, like replace this with some value, right, this column Na values replace with certain value. Okay. Again, this will be much clear when we actually do the hands on. So we'll now go and do the hands on. I just want to mention that there is another such package which is also very useful for data transformation, and we'll talk about this in the next class. Is called DPLYR. Okay, so again, we'll not talk about this in this class. We'll go on to this in the next class. Okay, so let's now move on to the hands-on part. There are two parts. In the first part, we'll talk about the GG scatter. Right, we'll create a scatter plot using GG scatter function, and in the second part, we'll look into the tidyr functions. Right, so the functions that we have discussed here. Okay, so let's move on to R. So here is the R console. Let's see the directory where we are. Okay, so we are inside the class 12 directory. So let's first look into the ggplot2 GG scatter, and here we have the GG scatter. Okay, so GG scatter. So I have compiled the code already. I'll explain whatever we are doing here, but we also want to have a look at the data set. Okay, so the data set that we are using is a new data set. I'll just load this data here, and let's call this table. Yeah, ggplot2. Then we have formatted Okay, so this is the data set ggplot2 GG scatter formatted filtered data. Let's look at this data set first. This is how the data looks like. It's not that important to actually go into all the details of what this data is looking at, but as you can see, this is something related with protein synthesis rate, average expression, average mRNA per cell, etc., and average expression, the noise value, etc. And then there is a measure called TAI full.1. Right, this is something some of you may be familiar with. This tRNA adaptation index. Again, this kind of tells us how efficient translation process is. And then we also have something called K-on or real protein synthesis per mRNA, etc. These values. Okay, so here are the values. Here are the columns. So and I can do this. Right, we can know the names of the columns. We don't really need to go into all the nitty-gritties of the data, how this data was generated. So the goal is to actually look into correlation between some of these. Okay, so we want to generate a scatter plot and look at correlation between some of these parameters. So we have already done this correlation analysis before, but we'll use GG scatter, right? And there are two parameters that we'll be looking at. For example, the TAI full one, okay, versus the real protein synthesis per mRNA. Okay. Now, one of the things that we, as I mentioned, is TI full. It means we are looking at tRNA adaptation index, which means it's kind of looking at translation speed. Okay. And there is another one which is real protein synthesis rate per mRNA, right. So this is again looking at translation speed. So I think we want to see correlation between these two measures, right, how well they are correlated. Okay. So that's the idea, and we can ignore the rest. Okay. But you can apply this for any measure, right, that you are interested in. Okay. So what we will do first is we want to remove these where only you have Na values, right. So because Na values will not give us any correlation. Okay. So that's the first step. We want to filter out this Na, and that's the first process here in the first line, right. We have loaded the data, then we have to do some Na filtering. Okay. So we have to remove Na, and then we'll use the GG scatter function. Okay. Now, before I go into all these operations, so I'll show you first. So we need to load this ggplot2 and ggpub. So these are ggpub helps us in preparing some publication ready. So images, so we can actually customize this very nicely. So we have loaded this. So GG scatter is a part of ggplot2, so we don't have to use anything here. Now what we do, I think last time we mentioned, right, we can set this theme, right. So last time we said, for example, theme minimal or theme black and white, those kind of things, right. So we can set this theme beforehand before we actually go into the plotting part, okay. And okay, so let's do this. So let's I'll use this theme set theme minimal, okay. Okay, we are setting the theme for the plot, and then we can also set theme, right, by specifying the what should be the size of the fonts on the x6 title, x6 text, etc. So all these things we can specify beforehand, okay, in ggplot2 by setting the theme, okay. And here we are defining our own theme called my theme, right, is equal to theme, and we are defining, as you can see, axis title, okay, and axis text size, so element text size 12, size 16, etc. Okay, so you can change these parameters as you wish, and you can customize these depending on how they appear after you have done the plot. Okay, so we have set the theme, and we'll use this theme later on when you go into the plotting part. Okay. Okay, so now we are done with the theme setting part, and this will persist. This will be in the environment, so we can probably check if it's there or not. Okay, you see this, my theme is there, and the table, the tab file, the data that we loaded is there. So the first processing is removing the NA values, right, because if you have NA values, you are not going to get any correlation. Okay, so I'll explain this, right. So we are removing this NA tab, right, which is, so this is how we are filtering out the values, and we discussed this very briefly. You can have these commands in here, right. So inside this bracket, so only choose those values where tab $ti full 1 is equal to false, right. So this is how we check whether it's NA or not. If it is NA equals to false, equal to false, so which means this is not an NA value, and is NA tab real protein synthesis rate per mRNA, this is also false, right. Both should be false, otherwise there is no correlation, you will not get any correlation. Okay, and you choose only those rows, right. So the rows are genes here, so only those rows where both are non-NA values, because only then you are going to get correlation. Okay, so you can have very complex arguments, right, for choosing the elements of a matrix or a table or a data frame. Okay. All right, so let's see, we have, okay, so it will remain the same. What I'll do is, so I will compare the dimensions, and let's see, this was the original dimension of the table, 2160 rows, 14 columns, and for init tab, let's see, you see the number of rows actually have decreased a lot, right, it's now 775. Okay, the columns will not change, they will remain the same, and we have reduced the number of genes for which we have non-NA values, right. So you can do this kind of filtering for any column that you like, etc., based on any values, etc., any columns, any parameters. When you are thinking about this, how to process is, sometimes it's also good to think about maybe getting rid of columns for which most of the values are NA values, right. So in that case, you do not lose a lot of genes in the pre-filtering step, right, or filtering step. Okay, so this is NA tab, right. So this is the we have removed the NA values. Now we'll do the GG scatter. Okay, so here is GG scatter. What you see, right. So this is how we are defining GG scatter. Okay, step by step. Take this data. X is Ti full dot 1, Y is real protein synthesis per mRNA dot 1. Okay, so this we are defined. This is the data. This is the X value. This is the Y value, right. So we'll do the scatter plot using these X values and Y values. We'll get the correlation between these two values. Then here are some arguments you can see. So add regression line. Okay, this is the trend line that will be added. Add confidence interval, right. So it's saying confidence interval equals to true, right. So add confidence interval. As I said, this will add 95% confidence interval. It will add the color of this now, right, and add parameters. So, it will fill up the blue color in the confidence interval as you see, and then we are here we are using GG theme minimal. Okay. So, here is the function. So, let us type this. You can type this over multiple lines in R. Then we are adding plus. So, so as I said earlier and I showed you, right, in ggplot2 you have to say ggplot2 plus something plus this plus that, etc. We have done the GG scatter part. Now we have to go into the stat correlation, right. We are saying stat correlation method equals to Pearson. You can change this to method equals to Spearman as well. Okay. Then we have the my theme part. Okay. So, let's copy this first. Pearson, okay, plus my theme. Then we are setting y limit, right. What should be the limit for y axis? The labels, right. X is equal to tRNA adaptation index or TAI as I said, and y equals to protein synthesis rate per mRNA. Okay. Okay. So, these are the extra additions here, and you can see we end up with a very nice plot. Okay. Now, it might say yeah, so you remove 7 rows containing non-finite outside the scale range. So, there might be some 7 rows that might have values greater than 1 here perhaps. So, that is something they have removed. So, you may want to increase the y limit, right, in that case, okay, or maybe just do not put any y limit. So, anyway, so this is kind of the data that you get. Okay, this is the kind of plot using GG scatter. You can see it is very nice, and it is also optimized already, right, all the font size, etc. Because we have set the theme already, right, for the x axis levels, y axis levels, etc. So, we can use this plot, right, already in presentations, etc., wherever we like. Okay. So, this is what we will do. We will save this, right. So, the command is def copy to PDF file correlation, right. Okay. So, this is something we can do, and we save that as a PDF file. Okay. So, we can now change different parameters. You can use this function for correlation between different parameters. We can play around with different features, etc. And I would urge you to actually explore, so that you understand like how each parameter affects the plot. Okay. So, we have now covered the GG scatter part, that we have skipped the scatter plot, and we have saved it. The next part that we want to do is we want to look at some of the tidyr commands, right, which we described just now. Okay. So, what I will do, I will also show you, right, where you can find this tidyr package, and where you can explore a lot more commands, right. So, here tidyr, right, this is the tidyr package, and here you have a discussion on all these commands, right, you can see. Okay. And we can load these by saying library tidyr. Okay. So, let us try this out now, some of these functions that we mentioned. Okay. So, first I will load library okay, or you can load library tidy first. So, tidyr is a part of tidyverse. So, we can load that, and here I am defining a table. Okay, right. So, this is how it would be: sample C, sample 1, sample 2, GNA ISO 1. So, this is the GNA isoform, GNA isoform 2, right, and gene B. Okay. This is similar to what we have seen, right, in the presentation. So, I convert this to data frame. It is okay. The functions will also work on table, right. I just want to show you this is also possible. So, let us say we write data, and it immediately, if it is a table, it will show you this is a table 2 by 4, okay, 2 rows 4 columns. The difference, as you see here, it shows you what type of data you have in each column. Okay, you have double. So, double means float, and then you have this is character, right. So, here is the sample name. Compared to that, right, if I say a df, it does not show anything, right, it does not show any of these values, etc. Right. Okay. So, we can work with any of these, all of these functions will work. So, let us try first the unite function. Okay. So, I have created this unite function. and as you can see here, the unit function, right, it will separate out, it will join these two columns, right. So, it has joined these columns ISO 1, ISO 2 into one single column. Okay, this is something you have seen. We can regenerate back, we get the original data, right, by saying separate, right, and we have seen this, how this works, right, how these commands work. We are saying into these columns. So, the new column names we have defined. So, let us see, renewed. Okay. So, you can see we get the original data back with this separate out. Okay. Okay, so we have tried out unit separate. We can also separate, for example, the separate longer delim. Okay. So, for that we can use this united df, right, and separate longer delim, right. This is different, it says longer df. You can see this is different, right. So, it actually is creating new columns, new rows to actually separate these isoforms. Okay. All right. So, we have tried these unite and separate functions. Now, let us try the pivot functions, right. The idea is very similar, right. Pivot longer, right. There was one command. Here is the data frame, columns to 3, names to GNA isoforms and values to value, right. So, these are the names of the new columns from where this column 2 and 3 will be put. Okay. Okay. So, we have done this, and once we run this command, this is what you get. Okay. So, this is a table 4 by 4, and as you can see, the GNP is now the second column here. Okay. And then we have created a new column, third column, which says GNA isoforms, and then it says GNA ISO 1, ISO 2, and then GNA ISO 1, ISO 2, and then it gives us the values. Okay. So, it is the same data represented in different ways, right. So, if you look at the original DF, this is how it was represented, and here this pivot long is represented in different ways. You might ask, why are you doing this pivot longer, etc. Because many programs, many functions, they want data in specific format. Okay. In those cases, these functions become very, very useful. And similarly, we can try the back to original DF, right. We can try the pivot wider on the pivot long DF, right. So, that we get the original data in the same format back. Okay. Okay, you see we are back to that original format. And the final thing that is remaining is to show how the drop works, right. So, drop I will show you on a different data, right. I will define a new data frame where you have some NA values, right. Otherwise, there is no way you will apply a drop, right. So, here you see you have NA values. Okay. You can simply say drop NA data gene ISO 1. So, you have to mention the column name where it will expect NA values, right, or you can also simply say drop data, right. So, you do not have to mention column, it will just drop wherever it finds NA, all the rows where it finds NA. Okay. You can also use the replace NA function. Okay. So, replace NA, right, it will replace the NA data with something else. Okay. So, here what we are doing, we are saying replace. So, GNA ISO 1, there is an NA value, replace this with mean of NA omit of the data GNA ISO 1. So, the mean value of that column, replace, use that value as a replacement for NA. Okay. And once we do that, you see the mean here is of course 54, there is only one value that is not NA, and it will get NA value, 54 value, right. So, it will replace the NA. Okay. So, with that we have illustrated all the functions that I mentioned in the presentation, but of course, there are many more functions I urge you to explore. So, here are some references where you will find all the details, the IDR, etc. And to conclude, so we have talked about data visualization with ggScatter, and then we have talked about data organization and data transformation. We had some hands on as well with that IDR package. So, with that I will close. In the next class we will be talking about the other package for data organization. Thank you.